Okay, let us discuss question number 1.82. So this is problem 1.82. Let me first make the diagram for this problem. Again, this problem is related to Newton's law. Only thing is I have to apply the concept of constraint. That is important in this case. So there is a prism. This angle is alpha. Mass of prism is m. And there is a pulley over this prism. And this is attached this side. And this also contains a mass, a small m. Now these threads are basically attached to this ball. Let me read the problem. In arrangement shown in figure 1.24, so this is figure number 1.24. Mass m of bar and capital mass M of base as well as base angle alpha are known. The masses of the pulley and threads are negligible. The friction is absent. Find the acceleration of base M. So find acceleration of M. Now you see again, basically, in which direction this mass will move? Because there is a normal reaction, this will apply a force on this. So this has a tendency to go in this direction. This block will move in this direction. Because the normal reaction that is pushing, so this mass is basically pushing this block. So this normal reaction will have one component in the downward direction, one component in this direction. So this block will move in this direction. Fairly simple. Everybody can understand. There is a normal reaction. This normal reaction will have component in this direction, in this direction also. So basically, one normal reaction component will press the earth. Another component will force this object to move in this direction. So let us try to see, first thing, what is the relationship between acceleration? So this will go this side and this will move this side. Let us work this problem in terms of relative concept, that is in terms of, because this object is moving over this and this itself is moving, so why not we work in terms of relative, that is the, let us say acceleration of this is A, that is the with respect to ground. Now what is the acceleration with respect to this object for this? Let us say if this goes by distance x, so this x length of the string will be free. If this length is x is free, now this x length is now available on this surface, the inclined surface. The same length, this, if this moves from here to here, so this comes from here to here, so this pulley, if this comes from here to here, so let us say this length is x, are you getting or not? So this length is x, that will become free. And now the same length that is free will now part of this incline. So here we have incline. So this same length will now go on incline. So you see, the object will also move in this direction by distance x. So if this moves by distance x, this also moves by distance x with respect to this. Are you getting? So now I can say acceleration of this is A in this direction. Acceleration of this is also A in the downward direction with respect to this base. This is the only important point in this question. Let us try to understand once again. This mass, if this mass goes with distance x, this thread is now free. If this reaches here, this thread is free. Now this thread will go over this incline. Now incline will basically here. So this thread is on incline. So if somebody is sitting on the incline, we'll find there is an increase of thread length by x. So acceleration of A, this is A, if I differentiate, acceleration of this is A, so acceleration of this block with respect to incline is also A. Are you getting? So let me make the free body diagram for these two objects. So if I make free body diagram, now we have to only make the free body diagram. So this is my small object, so there will be a tension. Are you getting? Now this is a friction force, this is a acceleration A in the downward direction, and this is with respect to base. Are you getting? So this is the acceleration with respect to base. Now there will be a normal reaction that will act on this subject. And there is a mg sin alpha and mg cos alpha that will also act. So let us say this direction you will have mg sin alpha. In this direction you will have mg cos alpha. Are you getting? Now for this object, let us draw the free body diagram for prism. So if you see the prism, there is a tension because the whole throughout the string will have same tension. This will act a tension T. There is also tension T in this direction. This angle is alpha. And there is a normal reaction that will act in this direction. The same normal reaction. Now this normal reaction will have a two component. There is no point to make this side, because if I make equation in this direction, I will have another unknown normal reaction from the ground. So I am only interested in normal reaction component this side. So if this angle is alpha, this angle is also alpha, this angle is 90 minus alpha. So n cos 90 minus alpha, this becomes n sin alpha. Now this angle is alpha, so this angle is again alpha. Are you getting? So this side you have t, so this side will have t cos alpha. So you can say in this direction component of tension will be t cos alpha. Because in this direction you have tension t, let us put it here. So in this direction you have t. So in this direction you will have t cos alpha. In this direction you will have n sin alpha. Now this object is basically going in this direction with acceleration a. Only one point is missing on this object. I have to apply a pseudo force. Because this acceleration is with respect to the base. So I have to apply, so this is going this direction with A. So I have to apply a pseudo force MA. So this is the pseudo force that I have to apply. Are you getting? Now I have to take the component of pseudo force. If this angle is alpha, are you getting? So this angle is alpha basically. So this angle will also alpha. You can verify yourself. So in this direction you will have MA cos alpha. So this side you will have MA cos alpha. And this side you will have MA sin alpha. Are you getting or not? So you see, you can verify yourself. So let me show you. So this is my base. And this angle is alpha. Pseudo force is acting in this direction. Now this angle is alpha. So this angle is also alpha. Are you getting or not? If this angle is alpha, then inclined towards the incline, this force will be MA cos alpha, perpendicular to the incline, MA sin alpha. Are you getting? So we will have MA cos alpha towards the incline, and perpendicular to incline you will have MA sin alpha. Let us plug all this value and then we will write equations. And then solving equation is your task. I am not going to solve the equation. Let us write equation for this object. So this side we have force T minus T cos alpha plus n sin alpha is equals to mass into acceleration. So mass of this object is capital M. Acceleration is A. So this is my equation number 1. Now for this I have to write two equations. In this direction there is no acceleration. So mg cos alpha is equals to, in this direction you have n plus ma sin alpha. This is my equation number 2. Are you getting? The total downward force, that is mg cos alpha, this side you have n plus ma sin alpha. Now third equation, this block moves this side with acceleration a. So mg sin alpha and I think you have written this one, mg sin alpha plus ma cos alpha, that is also acting downward. Any other force downward direction? No other force basically acting. So this is equals to mass into acceleration. So you can solve for, so basically you can solve for A from here itself. So what is the A? So this is g sin alpha. This is equals to A 1 minus cos alpha. So A is g sin alpha divided by 1 minus cos alpha. Are you getting? So basically we have done one mistake. And this mistake, tension, oh, we have left this tension. So there is a tension that is also acting up. So I have to basically, so this equation is, I have to modify this equation. Let me rub this one. I think you have copied this one. So let us rub this one. So what will happen, this side you have tension, so you will have, third equation has to be modified, mg sin alpha, that is in the downward direction, plus ma cos alpha minus t. Are you getting? So this you can rub, is equals to mass into acceleration. So mass is m and acceleration is e. So we have three equations. Equation 1, 2 and 3. Are you getting? So you can copy these three equations. This equation, this equation and this equation. So I have unknown t and a. We can always solve for a. So let us try to proceed for solving a. If you can solve this, then that is fine. Otherwise I will solve. Okay, let us try to solve. How we will solve? So I can find n from here and I can put n here, and then I can eliminate t. So let us find n from equation number 2 and put in 1. So we have t 1 minus cos alpha plus n sin alpha, and n is what? mg cos alpha minus ma sin alpha. So mg cos alpha minus ma sin alpha. This is normal reaction. So this normal reaction into sin alpha, this is equals to ma. So we have used equation number 1 and used equation number 2. Now let us use equation number 3. If I multiply equation number 3 by 1 minus cos alpha, so we will have mg sin alpha. I think you are able to see this one, slightly difficult. Mg sin alpha into 1 minus cos alpha plus ma cos alpha into 1 minus cos alpha minus t 1 minus cos alpha. This is equals to ma 1 minus cos alpha. Are you getting? So basically I am multiplying by 1 minus cos alpha both sides. I think you have copied this one. Now if I add these two equations, so slightly tedious job. So 1 minus cos alpha into t, 1 minus cos alpha into t goes out. So now what we will have? We will have mg cos alpha into sin alpha. I am also having the same thing, mg sin alpha cos alpha with minus sign. So there is, this term will basically cancel out. So mg cos alpha into sin alpha, here also I have mg sin alpha into cos alpha with minus sign. So this term goes out. Now this is minus ma sin square alpha, and here you will have minus ma cos square alpha. This is ma sin square alpha plus a minus, so I can write this side ma, because sin square alpha plus cos square alpha is 1. Ma sin square alpha minus ma cos square alpha, this is 1. Are you getting? So this term we have considered. This term we have considered. Now what are the terms that is left? I have left this term mg sin alpha here, and this term ma cos alpha. So this side the terms are left mg sin alpha minus ma, and this term is left plus ma cos alpha. This is equals to this side. What we have? We have ma 1 minus cos alpha plus ma. Now see, can I still cancel some more terms? So let us take all these a this side. So we will have mg sin alpha, slightly difficult, Now this MA plus MA, so we will have 2MA. This MA cos alpha, this side MA cos alpha, so we will have minus 2MA cos alpha. Plus MA. So if you take A common and then you divide by this side, so you will have mg sin alpha. I am slightly feared. Maybe somewhere I have done mistake, and that's why I am feared. If I have done mistake, then I have to do the same video again. Not same video again, I can modify basically. But still I am slightly feared. So you have 2m here minus 2m cos alpha plus m. Are you getting or not? So I can see mg sin alpha. This side if I take 2m common, I will have 1 minus cos alpha plus m. Are you getting? Now let me check the answer. If I get the answer, I will be happy. Yeah, same answer. Mg sin alpha divided by capital M plus 2m 1 minus cos alpha. Okay, so I am really happy because solving these equations, nobody knows where I can do the mistake. And if I do the mistake, it's very difficult to figure out. Of course, we will find it out, but it takes time. So this question, so what are the important points in this question? You have two important points. If I apply the pseudo force, writing equation of motion becomes slightly easy. Second important point we have, that is acceleration of block is A, then acceleration of this small rod is also A with respect to the base. And if I have assumed that acceleration of rod is A with respect to base, then I have to apply a pseudo force on the rod, because base itself is a non-inertial frame, because base itself is moving right with acceleration A. Anything that is moving with acceleration becomes a non-inertial frame. And if you want to take an acceleration with respect to that non-inertial frame, then you have to apply a pseudo force. And that we have done. So this is this concept. So two important points in this question we have said, that is the pseudo force and the constraint equation. In this case, constraint equation we have found, if this base goes by distance x, then the prism, that is the prism or base, moves by distance x, then the strings become slackened by distance x, and this slackened length will fall over this prism, incline of prism. So on incline of prism there is x extra length. So this means this block, that is the rod, will fall by x length towards the prism, all over this incline of prism. So this means acceleration of prism is A, then acceleration of this rod is also A with respect to the prism. That is the important point. And then if I assume this with respect to the prism, then I have to apply a pseudo force. I think all of you have copied this one. And if you have copied, then I can go for the next problem. Okay, let us finish it here and go for the next problem.